So now we have integral E dotted into dl is equal to negative d phi b dt. So remember, we covered the modified Ampere's law the other day, and we said it was B dotted into dl was mu 0 E 0 d phi E dt. So then this said that if you change the electric flux over time, you create a magnetic field. So remember, that was modified because it was added to this one, mu 0 I, and then this one was called the displacement current. Okay, so if you change the electrical flux multiplied by E0, it creates displacement current, but often it is a very small number because it's multiplied by a small number here. So it's an effect that's not noticeable unless perhaps you get a situation where the current is 0, then you can create a field that is noticeable. Of course, in a vacuum, electromagnetic fields utilize this law to create magnetism. And of course, changing magnetic field, so this is the opposite of that law. The changing magnetic flux creates electric field, you see. Now, this has more practical daily implications because, first of all, there is no mu 0 E 0 thing. So it's a straight out, if you change the magnetic flux over time, you create an electric field, and it's a much bigger electric field, more noticeable electric field. So nature did it where this effect is a more smaller effect, not as noticeable than this effect. You can change the magnetic field and you create an electric field. And the other thing that's more interesting about this law is that creating electric field, you're essentially creating voltage, because electric field times length, that's all EMF, that's a voltage. So essentially you're creating, and of course if you have more loops, then you're creating every single loop that you have, you multiply this by n, and you're creating a bigger EMF. So this acts as a source to create electric field and, of course, voltage across a wire. So we have here E dotted into dl, negative d by dt, and then flux is B dotted into dA, and then when you so this is just focusing in on the integral portion, and then you have here E dotted into dl, negative d by dt. So then you have here, for most cases we're going to do, the B is going to be constant over the area. So we're just going to worry about BA cosine theta. But I'll show you a case where the B is also not constant. Then we have to integrate. So then the three main ways of creating electric field is to either change the B, change the A, or change the angle between the B and the A. And then that way you create electric field. And then the negative has to do with something known as Lenz's law. Lenz's law. So you see, this one doesn't have a negative, but this one does have a negative. So one of these has to have a negative, because otherwise it'll be, well, you will basically violate the law of entropy if both of them were positive. Okay. Then if you do the multiply this by n, that will be the EMF, n times E dl is equal to negative n d phi dt BA cosine theta. And then that will be the total voltage that you have created in that wire. So let's focus on different ways that you could create electric field. One, let's say you're just changing the magnetic field first. So